Hi folks, welcome and thank you for joining my session. I'm Jeong Kim from Line OpenJet Server Dev Team. In this session, I'd like to share how we improved our event delivery mechanism by introducing debouncing on the server side. In the following 10 minutes, we will walk through OpenJet's event delivery mechanism and its problem of bursting notifications. We will see how throttling comes to our rescue first, and then debouncing is a next better alternative with the same performance improvements. Finally, we will see how we can do even better in the future. So what is the event delivery mechanism and how is it related to debouncing? The event delivery mechanism is the heart of OpenJet's architecture, and it is what both enables and requires debouncing as an improvement. Let's see why. In OpenJet, users are busy with all different kinds of activities. They join and leave chat rooms, send and read messages, make announcements, and post pictures, and so on. And all these activities are treated by OpenJet Server in terms of events. There are millions of new events every minute in OpenJet. Now suppose these events had to be delivered for every update. That'll be neither scalable nor efficient when we have millions of updates per second and per chat room. The good thing is, we don't need to store and deliver all past updates, because for each object, what matters is only the latest information. When we open up the app, what we want to see is things as they are right now. So OpenJet Server groups and merges events by their types and targets to reduce events of each kind to the latest state. And clients can fetch only the latest state of only what has changed since they were last online. So far, everything seems fine. Now where's the problem? The problem is that we need to notify users about the occurrence and presence of updates. When they're offline, clients don't need to retrieve all the past updates, but still, they do need to know that there are new updates to know whether to fetch new events or not. And when updates start flooding in, we get bursting notifications. Bursting notifications are a problem because we use our storages heavily to identify which users to notify and build notifications, and especially in busy chats where clients are online and ready to respond, the benefit from merging events is canceled out by immediate fetches caused by notifications. Actually, in the previous year's session about OpenJet's architecture, this problem was mentioned as an obstacle to tackle in the future. We've managed to mitigate the problem by asynchronous distributed event handling as introduced before, but the total number of notifications itself remains the same, and the problem is still there. So we must limit the total number of notifications. And our first response was to apply throttling, very simple and effective. By throttling, we can limit the total number by taking only the first few in each interval. Yet, throttling has another problem. See how clients get only the older events at the beginning of each time window, even when there are new ones at the end. Indeed, clients will get new updates once in a while, but not always the latest ones. In terms of both technical design and data consistency, just sitting and waiting for eventual consistency is not good enough. Instead, we want to always ensure that the latest information is notified and delivered in each time frame. Our requirement to ensure the latest delivery reflects the very definition of debouncing, to sample the latest event that matters. I think many of you have already heard of or actually tried debouncing, especially in client-side contexts. So let's take a look at a client-side example first. Search autocomplete will be a good example where the client suggests queries that we may intend on each key input. Now suppose the client sent a request for each key input. Then too many requests would be wasted because even before retrieving a response for a previous key, we can be typing in new characters without seeing the result. And this is where debouncing helps. The client can send requests for the last few keys only when we get stuck and stop typing in for a while. After all, this is when we mostly need autocomplete. So the debouncing client ignores all our bouncing keystrokes in the middle and takes only the latest ones within a time frame. Back to our case, we want to apply the same technique on the server side to notify clients about the latest events only. The only difference is that while the autocomplete client can defer requests indefinitely as long as the input continues, we need a timeout to notify events at least once in a while to ensure consistent delivery. And this strategy fits well into our architecture where events are merged to the latest, so notifying only the last one wouldn't compromise anything. Now let's see how debouncing is implemented within our event delivery. The implementation takes place within the flow of event publishing, where event-related tasks, including notification, are distributed and delegated to corresponding task handlers. In our redesign, we keep the overall flow the same, because it's already good at distributing and handling events by each type. Instead, the main change takes place here within task handlers. The previous design was straightforward. Handlers just do handle tasks. Now we have new helpers. Handlers let the switcher decide a go, no-go for rate limiting, and the switcher delegates the actual flow control to either debouncer or throttler. Inside the newly introduced debouncer, we have 3 requirements. The first one is the basic feature of debouncing, as we all know. Second, we want a dynamic and fine-grained control over our configurations to respond to ever-changing situations in line OpenChat. Lastly, we want to respect urgent updates that may bypass rate limiting. And we met those requirements by tweaking our previous implementation with the help of several libraries. First, we implement the core logic with Bucket for Java and Caffeine. Second, dynamic configuration is made simple by Central Dogma, which we already use in our servers to review and apply new configurations within a matter of milliseconds. With Bucket for Java and Caffeine, we maintain cached buckets so that we manage multiple candidates to rate limit and specify when and how to handle them. And with Central Dogma, we can configure the threshold and the effective scope of rate limiting. For the third requirement of conditional bypassing, each task handler's implementation takes care of those special requirements. For example, the handler for message notifications prioritizes mentions or replies because they are usually meant to be delivered quickly. Debouncers can then accommodate each handler's unique requirement in their flow control. For example, the message handler's debouncer respects prioritized mentions and replies and let them bypass the rate limit as immediate targets. Now let's see how debouncing solves the problems that we saw at the beginning. Previously, bursting notifications caused hotspots and wastes in our storages, network traffics, and computational resources. Now those bursts are kept in control. Take a look at this chat room, busy at night for example, where activities increase by 2 times within several minutes. If we debounce the resulting notifications, keeping a 5-second window with a moderate threshold, we can flatten the spikes and bursts in the middle. Bursts and hotspots in our storage usage are now also kept in control. By limiting the total number of notifications, we can also cut the required number of storage access dramatically, almost by 4 times. Let me sum up the improvement. Previously, notifications used to burst together with events, leading to hotspots in storages and more round trips to keep up with more fetches caused by those notifications. With debouncing, these are kept within a limit that we can configure. And we get all these benefits while maintaining the same smooth user experience and data consistency. Now, is there any room for more improvements? Even at this moment, many new exciting features for OpenChat are in development. I can't give you out the full details now, but they will be also implemented in terms of events in our architecture. The new event types will then also benefit from merged delivery, which is now made even more efficient by debounce notification. With our new improvements, we look forward to serving you those features with the same reliable and smooth user experience, even when you're in the middle of busy and bustling chat rooms, with no lags, no glitches, and no technical difficulty. Thank you, and I hope you enjoyed the session.